My name is Brandon Roberts. I'm a senior software engineer, and you can follow me on Twitter at Brandon T. Roberts.
And I'm Mike Ryan. I'm also a senior software engineer, and you can follow me at Mike Ryan Dev. And we both work at Synapse. They're an industrial Internet of Things company where we get to build high-performance, reactive user interfaces in Angular. So today, we're going to be taking an app from inactive to reactive. And if you want to follow along, you can follow us on ngrx. It's a community project started by Rob Wormald. We build small reactive libraries for Angular. So we look at what are the hard problems when trying to build reactive applications, and how can we build small, concise libraries to solve those problems. You can find us at github.com/ngrx. All of the projects that we're going to be talking about today can be found there. If you want to work through the workshop with us, you can. Just clone the repo. It's at github.com/codesequence/ngrx-workshop. We will post the slides there after the talk today. So once you get it all set up, the app that we're going to be starting on is going to look like this. It's a simple book search app where you can type in a term and you can get book results back. But this application is currently rather inactive. And the way it works is we have this search page component. And it has a child, a search input. When the user queries for books, it's going to emit an output event to the search page. The search page is going to take that query and ask the Google Books API for a list of books that match that query. Once it gets results back, it's going to flow that to a search results component and display all the books. But let's imagine we want to add a new feature. We want to show the number of results found when you search for books. We don't want to make another HTTP request to get this information, but ideally, we want to keep the count in sync. If we're showing 60 books, then the counter needs to say 60 results found. Well, if we take our application as it exists today, we can imagine how we might flow this through inputs and outputs. The search page would still get a query from the search input. We'd still reach out to the Google Books API to get books back. And we could flow this down to a new search results count component that we'll write today. And this would work for this simple app, but we often don't get the luxury of building simple apps. We're building complex apps. And so imagine if we had a much richer component hierarchy, and that search results and search results count were deeply nested children of the parent. Well, for those book results to flow down this component tree, we'd have to cross a lot of mid-tier components. And this is a problem we see come up in a lot of these rich, complex applications. So what we need to be able to do is we need to be able to share state across components. We don't want to use inputs to share the results. We want to go outside of the input tree and share results so that those mid-tier components don't have to even think about the books. So that's where the first library that we're going to talk about comes in, ngrx store. It's an RxJS-powered state management container for Angular apps. It's inspired heavily based on Redux. And the way it works is we're going to have components, and when the user interacts with these components, we're going to take those events and we're going to model them in a consistent way using actions. We're going to write a reducer function today that takes those actions and reduces them into state. Then that state is going to be delivered to our components in an observable service. So first, let's talk about actions. In order to represent all of our UI events and HTTP responses in a consistent way, we have to add hair to this action interface. And an action interface has one required property, a type. And that type needs to be a string, and it needs to be unique amongst all actions in our application. We can optionally have a payload, and this can have any kind of data. In our actions, it might have the search query, or it might have the list of results that we get back from the Google Books API. So let's go ahead and dive into the code and represent our UI events and HTTP responses as actions.
Okay, so to model our UI events and HTTP responses as actions, we'll go ahead and create those. So I'll go into the app folder, and I'll create a file called search actions. And first, we'll import a few things that we'll need. So first, I've imported the action interface from ngrx store that gives you the interface that we have to use to type. And I've also imported the book that I've created previously that provides an interface for the model that is returned by the Google Books API. So next, we'll create some action types. So here, I've created two action types. The first one being search, which are defined as a string, which we'll use in our actions later. And search success, well, we use the search when we enter the search query before we hit the API, and then once we hit the API later, we'll return those search results using the search success action type. Now, as he stated, each one of these needs to be unique because over time you'll have more actions, and you want these actions to be, they'll need to be unique, and you want them to be easily readable. And you also, as you see here, I have the books. I've also added a namespace named books because you'll have a lot of actions, and you want to kind of group those different actions according to the things that you'll be doing. So next, I'll create our actions. So we have the search action that implements the action interface. It has the read-only type of search, and it also has a payload, which will be a string that will come back when we enter our search query. And we also have search success, which uses the search success type, but this one provides a payload, which is an array of books. Now, if you're familiar with Redux, you can use plain JavaScript objects when you're defining actions. But we're using classes because we can take advantage of TypeScript's powerful type checking, and it also gives you help in your IDE when you're dispatching these actions to make sure that you're entering the right data for the payload if you need one. Next, we'll export a type that exports all of these actions that we can use in our reducer. And we'll just call this type all. So it'll give us that action we can go against when we do our reducer and when we reduce our state later on.
So now that we've represented our UI events and HTTP responses as actions, we need to move on to the reducer. And this reducer is a special function. It takes in the previous state and an action that we're going to dispatch and returns the new state. And while it's a simple interface, I want to point out a few gotchas when you're building this. The first, when our application starts up, state is going to be undefined. So this reducer function needs to know how to initialize state. The second is it always needs to return a new state object. It needs to be pure in that regard and return an immutable state so that we're not mutating previous instances of that state object. We also don't want to write one reducer for our entire application. As we build complex applications, we're going to have a lot of state to manage, and if we try to do that in one reducer, that would get unwieldy really quickly. So ngrx store abstracts away that application reducer, and instead, we're going to delegate state and actions to child reducers that only work on one piece of the state. So today, we're just going to do the book reducer, but as we might expand this to add authentication and layout in the future, we could add new reducers to manage their own individual slices of state. And you can think of these sort of like tables in a database. So when they create their state, they're going to be aggregated into one large state object called the application state. So let's go ahead and write that book reducer and get it registered with ngrx store.
Okay, so we've defined our action, and now we want to create our reducer. So I'll create a file called search reducer. And we'll also need to import some things there. So I've imported the book model again and imported the search actions that we just created. Next, we'll need to define an interface for this piece of state. So for this, we'll just define this interface as state, and it has two properties. The search term, which is what we enter when we enter the search, and the results that are returned when we return our array of books. Now, as Mike stated, this reducer will be initially undefined, so we'll need to give this state an initial state. So we'll define an initial state with search terms as an empty string and an empty array of results, but it will be populated later when we dispatch actions. Next, we'll do the reducer. So the reducer is a function of state. It takes the current state in, and initially we'll have our initial state and the current action. And you see we have our search actions.all that we exported, which has all the actions that we want to handle in this reducer. And we'll return the new state. And since we're going to key off certain actions, we'll just use a switch statement to go through each action that we want to handle. So in our first case, we're handling the search terms, which is what is entered when they perform their query. So we want to return a new object, and we'll take the current state, and we'll use the spread operator to copy those properties from the current state into that new object, and use the payload, which is a string, to modify the search terms and put that data into the store. We also have the search success, which does the same thing of copying the current state properties into the new object and returning a payload. We'll use the payload, which is an array of books. Now, we'll have multiple reducers as your application grows, but not all reducers handle all actions. But we always need to return a state, whether you're handling the action in the reducer or not. So by default, if you're not handling the action here, you'll just return the state as it was passed in. So now that we've defined our search reducer, we'll define an overall application state, overall state for our application. So I'll create a new file called reducers, and we'll import the search reducer that we just created. Now we'll need to model our overall application state kind of similarly to the way that we did the search state. And it's just another interface that we can use to type against when we're selecting state and dispatching actions. Now we'll also create an object that contains all of our reducers that are combined together for delegation. And so this is our reducer object, which will make up our application state. So now that we have our reducers defined, we can register that within our application. So I'll go into the app module, and I'll import a couple of things. The store module, which is an ng module that is integrated with Angular, that provides the store, and we'll also import the reducers that we'll need to provide our state with that global, to provide our application with that global state. So I'll go to the imports, and I'll register our reducers in the application, giving us that global store service and state management that we'll use later on.
Okay, so we've written our actions and we've written our reducer, but now we need to inject the store service into our components to bring it all together. The store is a special service, and it's an observable of our application state. It has one special operator, the select operator. Because we have one large state object, components are only going to be concerned with some small piece of that state object. So select takes a function that allows you to select that part of state, and it returns an observable of only changes to that piece of state. It also has a dispatch method, and this is how components are going to dispatch actions to the store. So let's go ahead and inject the store into our components and start dispatching actions and selecting state.
Okay, so since we have our store registered within our application, we can go into the search component and import some of the things that we'll need to dispatch actions and select state. First thing is the store service, which is available to anywhere within our application that we can inject. We also have the search actions, which includes the search and the search success. We've also imported everything from the reducers folder, which gives us the state interface so that we can use that to type against the store. Next, we'll update some of our components to use the store. So first we have the value, which is we have an input on our book search component, which uses terms which will be delivered as an observable when we wire it up to the store, but we haven't gotten that far yet. We also said that we wanted to create a count of results to be displayed. So I'll just create a simple search results card that displays a number of results. Also, the books we have defined as a simple array, but once it's wired up to the store, it will be delivered as an observable also. So we'll just use the async pipe. Use the async pipe to subscribe that to the store. Next, we'll update our class variables to be able to get to select those pieces of state. So we have our search terms, which is wired up to our search input. We have our array of books and our count. Next, we need to inject store. So we have our store injected. So now I want to update the onSearch method so that we can dispatch actions to the store when we perform our search and get our search results back. So now, instead of just doing the search locally in our component, when you enter a search query, we have the search terms, we dispatch an action that you're performing a search. We'll go and make the network request in our component, and once those results come back, we'll dispatch those results to the store. So now that data will be in the store, we can add some selectors to get that data out. So as we stated, the store has a select method that takes a callback function. And as Mike stated, the thing about the select is that you can select pieces of state, but even if your state is changing over time, these observables will only emit updates if something that you selected changes. So only when the search terms change is when we'll emit a new update. So now we save that. We can go back to our application, and once it reloads, we can perform a search and still get that same data, make that request, but we're pushing that data into the store. So our UI can react to what's in the store as opposed to storing that data locally in the component. Now, since we've already wired up our data into the store, we can move our search results into a separate card because we can access the store from anywhere. So let's go ahead and do that. So I'll create a new component. Call results count. And I'll go to the results count, and I'll import the things we'll need to wire up that component into the store. So we'll import our observable for type information in store, and also the store service and our reducers. So I'll update the template to use that card information that we had previously in the search component. And we'll also add some styles. And so our count variable is still red at the moment, but we'll go ahead and define that also. And I'll also inject store. And now I'll just add the selector to get that count, to select that count from the store. And now that we have that component, I can go back to the search component and use it instead of having it in this component, which gives that component less responsibility because the count can subscribe to the store and get that same data. So I'll create the app results count component. and then I can remove that count from the search component. Now I have two components that are wired up to the store, and I can still perform the same search and still get the same results.
Okay, so we're almost done implementing store, but there's still one part that's not quite finished. Right now, these components are using select to select the state they care about. This is still too much responsibility for our components. We want to write really clear, concise components that only care about wiring up data and dispatching actions. So instead of having them implement those select functions, we're going to refactor those out into selectors. And a selector is a function that takes app state and returns some selected state. And by refactoring these out into functions that we can share across components, we're reducing the responsibility of our components, and we can share them across our entire application. So let's refactor those selector functions out.
So like I said, we have our selectors here, callback function, but we want to store our selectors where our state is defined, which will give us an easy place to go to reference that. So I'll go ahead and add and create some selectors and then update our components. So the selectors, we want to follow a convention when you're selecting data from state using selector functions. So I'm going to have three selector functions here, one for select results, one to select the count, which is just the length of the array of books, and one for search terms. So now I can go, I'll save that, and I can go and update my two components, the search component, to use those selectors. So it's less responsibility of the component to know how to get that data. So I'll use, and we've already imported everything from reducers, so I'll just use from root to select the search terms. And also from root to select the search results. And then I'll go into the results count component and use a selector function there also. So now our components have less responsibility of how to get that data, but as I stated, we can still perform the same search and it still works exactly the same.
So that's the ngrx store. But there's still some, let's recap what we've done so far. We've said that all UI events and all HTTP requests can be modeled using a consistent action interface. We wrote a book reducer to manage the book state. It takes in actions and returns new state. This state is delivered to all components using a shared state service. So if we look at what our application looks like at this point, we now have store, who's sort of the single source of truth in this application. He's delivering state updates to the search page and the search results count. Search page gives the results and the search input term to its components. The search input, when it emits a query, is wrapped in an action and dispatched to store. But there's one part here that's still a little awkward. And that's that the search page is still making that request to the Google Books API. And we can consider this search to be a side effect. So a side effect is any code that interacts with the outside world. You can think of HTTP requests, WebSocket messages, offline data storage, and even time functions as being code that produces side effects. You don't know how they're going to behave when you run that code. So if we write our components without side effects and isolate them out from our component tree, it'd make them easier to test. And the reason for that is, if we think of state as a function that produces our UI, and for any state we're showing the same UI, we can make test assertions against that. We can say, how does our application behave underneath this state? Or what about this state? And they're pure representations of that state tree. So we need to be able to isolate our side effects from our components. And that's where ngrx effects comes in. It's a side effect model for ngrx store that allows you to write long-running processes that wrap side effects. Depending on how the side effect behaves, it will deliver those results as actions back to the store. So where do they fit in with this Redux model? Well, components are already dispatching really interesting things to actions. So if we represent actions as an observable, then we can listen for certain actions, perform our side effect, and then deliver new actions back to the store. Indirect Effects lets you do that with two key APIs. The first is an actions service, and he's an observable of all of the actions that are dispatched in your application. He has one special operator of type. You can give it an action type, like search, and it will return to an observable of all the times search is dispatched in your application. We'll use this in regular Angular services called effect services. They're injectable, and they're going to have these properties on them of action sources that Indirect Effects should subscribe to dispatch back to the store. We need to hint to Indirect Effects which properties to subscribe to, and we do that with the effect decorator. So let's go ahead and refactor our app and move that search request out of our component and into a side effect.
Okay, so next we'll create our effects. So I'll create a file called book effects. We're going to import a few things in this effect. The first one is the map operator, which takes the value that is emitted from one observable and returns it so it can be a new observable. We also have the switch map operator, which is similar to the map operator, but if you have an observable that doesn't finish and you emit a new observable from that, it will cancel the previous observable so that you can continue, so that you're always guaranteed you're working with the latest request. We have the injectable decorator and our effect decorator in actions. We also have observable and our action interfaces. We have the Google Book service to make the request and our search actions. So we'll go ahead and create the effect class, which is just an injectable service. And we want to inject the actions and the Google Book service into our effect. That gives us that action stream that we can key off of to perform those side effects. So now we'll add the effect to do the actual search. So I've defined a variable called search, and I've hinted it with the effect decorator. Each property that's hinted with that decorator has metadata that tells the effects, once they're registered, to subscribe that to the store. So any actions that come out of this effect will be mapped instantly into the store in our event loop. And we're going to return an observable of an action. So we use the action stream and we use the search action type to listen to. So we want to map that action that was provided when we enter the search terms and map it to its payload, which in this case is a string. We'll use the switch map operator to take our search terms, make our network request to the Google Books API, and get those results back. And as I stated, if the search API takes longer and we do a new search before that finishes, it will cancel that previous request. So we'll take those search results and map those into the search success, which is our array of books, which will update our store automatically. So now that we've done that, I can go into the search component. Well, now we have our effects that can go and register those effects. So I'll go into the app module and I'll import the effects module in our book effects. This will register the effects when the application starts to start listening for that global loop of each action that's dispatched so that we can perform the side effects. And as we did with the store module, I'll register this effect using effectsmodule.run, which starts that process. Now I can go, now that we've registered our effects, I can remove this responsibility from the search component. So we don't need the Google Book service anymore here because that is done in the effect. So we can actually remove that code from that component. So once the application is reloaded, I can search again. And we've performed the same action, but our component has a lot less responsibility.
Okay, let's recap effects. We've said that we have this action service, and we can use the of-type operator to listen for specific actions. Effects listen for those actions and return new sources of actions in response. Those are wired back up to the store, and in this way, we've isolated our side effects from our components, making our components a pure representation of state. Now, we've been saying that this gives you really good performance. So where did the performance part come in? Well, if we have data and we have an object and we want to change some property, Angular is intelligent and does this deep, dirty checking of your objects to see if it needs to re-render the UI. But our reducers are pure. We're taking existing objects, copying their property into a new object with just the change. So we really don't need Angular to perform this deep, dirty checking. We want to be able to say, Angular, only check if the object changed, like if the reference has changed. This would give us a significant speed up if we were dealing with thousands of books. So let's go ahead and refactor our app and see how difficult it is now to improve change detection performance.
Okay, so I'll go back to my search component, and we're going to change detection to take advantage of this. So I'll bring in the change detection strategy, and I'll also go into the component metadata to add this change detection strategy. So I'll use a change detection property and change the strategy to onPush and save. That's it.
So with one line, you immediately get these big performance gains because you built your application this way. You're going to get tremendous speed up when you're dealing with lots of objects.
We can still search, but we're not doing all those reference checks or deep, dirty checks. We're only doing reference checks, which can be a lot faster.
So we've also been saying if you use this, it's going to be easier to test. Well, how do we actually interact and test with this application? And that's where the ngrx store dev tools come in. And these are developer tools for ngrx store. And the way they work is we're already modeling this application as a series of changes to state via action. So it gives us a time travel debugger where we can go back in time to an individual state, inspect what changed, and see what action caused that change. It integrates with the Redux Dev Tools extension. This is a browser extension for Firefox and Chrome. You can go to their respective extension stores to download the extension. Let's see how difficult it is to wire this up into our application.
So I've already downloaded the extension, the Redux Dev Tools extension in my browser. So now we're going to wire up the extension to our application. So I'll go back to the app module and import the store dev tools. The store dev tools provides a bridge from our application to the Chrome extension, and it also instruments our store. So I'll add that to our imports. Now, the store dev tool instrument store will instrument each one of our reducers so that we can use that time traveling in our application and be able to go back in time to see what our state looks like at any given point in time. So I'll instrument store, and once my application reloads, you'll notice I have a green icon up here, which is the Redux Dev Tools extension. So I'll go ahead and open that. And it gives me an interface that I can use to see what the state of my application looks like. In the beginning, we talked about having an initial state. So we see our search piece of state, and I can see that it's an empty string, and it gives me an empty list of results. So if I search, I get the results, but I can see how I got there. I dispatched a search action when I entered a search query, and once that request was made using a side effect, it returned those results back, and I can see that I have search results now. So I go ahead and perform another search. And once again, I have more actions that's been dispatched. Now, how do we do time traveling? Well, as you saw in the slide, we can use the debugger, time traveling, to see what my state looked like one state ago. I can also go back to the beginning of before I even initiated a search. I can also roll this state forward to see what the state looks like as I'm dispatching actions along the way. Now, when we instrument our store, there is a performance penalty because we're dispatching actions, we're keeping state, and once our store is instrumented, we're keeping multiple sets of state and snapshots of that, so we can use that time traveling. But we may not want to do that all the time. So you may only want to instrument the store when you actually have the extension installed, so that when you're doing development, you will have that extension there that you can use for debugging, but in production, you won't pay that performance penalty. So we can change that with the store module and use instrument only with extension. So that way in development, like I said, you can use the tools, but when you distribute to production, you won't have that penalty.
So with one line, because we've built our application this way, we get really powerful debug tools for our application. So let's wrap up everything we've done so far. We've said that we can make state observable and immutable. It's observable so that components can register to changes in our state. It's immutable so that we can turn on the on-push change detection strategy to get big performance wins in our application. We have a shared state service called the store. This is how components select state, and it's how they dispatch actions. We've isolated our side effects out of our components using ngrx effects. This makes our components way easier to test, and they have a lot fewer responsibilities. If you want to see the full example, on the ngrx organization, we have the full example app. This is maintained by one of our ngrx team members, Ryan Jordan, and it expands on this search to include a full book collection feature. You can use ngrx router store to connect the Angular router to the store, so you can use the same time travel debugger for the router. And it also has ngrx db, which allows you to persist data across multiple sessions of the application. Before we go, I want to leave you with a quote. Redux is not great for making simple things quickly. It's great for making really hard things simple. So today we only had enough time to build something simple using these tools, but I hope you understand that these are meant for applications that have really hard state management problems. If you're not sure if you need ngrx, come talk to Brandon and I. We're going to be right outside the hallway after we get off stage, and we'll be here throughout the rest of the conference. You can also ask us anything in the Vienna room at 3. We'll be in the experts room at 4 if you want us to actually look at your application. Or if you just want to go through the tour of heroes with us, we'll do that at 5 in the Audubon room. Thank you.